Hello, good evening everyone. In the previous classes, that is a discussion about what is the difference between scalar and vector, what is the examples, what is the difference means, what is the definitions of scalar and vector, what is the representation of a vector, and what is the types of vectors. In this concepts are all these types of vectors is it is in the previous classes already discussed. In this class today discussion about algebraic of the vectors, algebraic of a vectors. See, the algebraic of a vectors is it is classified into two different types. One is a addition of a vector. First one is addition of a vector. Second one is subtraction of a vector. There are two. The algebraic of a vector is it is classified into two different types. One is the addition of a vector and second one is subtraction of a vector. First step is addition of a vector. What is the meaning of addition of a vector? The addition of a vector is defined as if vector A and vector B be the two vectors. Vector A and vector B be the two vectors. The sum of the two vectors is defined as vector R is equal to vector A plus vector B. That is the addition of a vector. Any two vectors, if vector A and vector B be the two vectors, what is a vector? It is a both magnitude and direction. The vector is a physical quantity, both magnitude and direction. That is called vector. That is called the sum of the any two vectors is called addition of a vector. The addition of a vector is it is a two different laws. There are two laws of the two different laws of addition of a vector. Addition of a vector. First one is triangle law or addition of the triangle, or the first law is called that is the triangle law of a vector. Triangle law of addition of a vector. The triangle law of a vector is it is defined as if see there is a one vector, the one more vector, and this is called vector A, this is called vector B. This line can be represented by resultant of a vector, resultant line, that is a diagonal line of the triangle. The triangle ABC, the triangle is ABC. The AB and BC is a adjacent sides. The line AC or CA is a diagonal line. According to the triangle law of a vector addition is if two vectors, vector A and vector B is acting at this position, it is acting at a point in equilibrium and it is represented by both magnitude and direction, and the diagonal line, the resultant line, it is also represented by both magnitude and direction of three sides of the triangle. That is the law of triangle law. The triangle law of addition of two vectors is according to this law states that is the two vectors is acting at a point in equilibrium. It is represented by both magnitude and direction. The resultant line, this is also called diagonal line. The resultant line, it is also represented by both magnitude and direction of three sides of a triangle. That is AB and BC and CA is the three sides of a triangle. That is given by vector R is equal to sum of the adjacent sides vector A and vector B. That is the formula of triangle law. That is a vector R is called resultant field, the resultant line, and vector A and vector B be the It is the adjacent sides of a vectors. Adjacent sides of a vector. This is the statement of a triangle. Now what is the explanation of this triangle law? List the triangle ABC, AB and BC be the 2 and CA, the AB and BC and CA is the 3 sides of a triangle. The each line can be represented by both magnitude and direction. Each side can be represented by both magnitude and direction, and that is vector A is the length of a vector AB, and vector B is the length of a CB, vector R is the length of a AC. That is the given by vector R is equal to vector A plus vector B. That is the statement and explanation of a triangle law. And the second law is law of parallelogram. Law of parallelogram. Law of a parallelogram. First to draw the parallelogram. The parallelogram this is called parallelogram. That is O, A and B, C is the parallelogram, and the line OC is called diagonal line. That is also called resultant line. The OA can be represented by vector A, and vector B, that is OB, is represented by vector what? B. Vector B. According to in this side, the OABC is the parallelogram. The OE and OP is the adjacent sides of a parallelogram, and the OC line can be represented by diagonal line. According to the law of parallelogram states that if two vectors is acting at a point in equilibrium, that is vector A and vector B is acting at a point in equilibrium, at a point is O. It is represented by both magnitude and direction. The OB can be represented by both magnitude and direction. It is equal to the resultant line. The resultant line, that is a vector R, that is also called what? That is a resultant line, diagonal line. The diagonal line, it is AC. The OC line is called, it is also called resultant line. The resultant line is also represented by, that is a both magnitude and direction of a the parallelogram OABC. That is the explanation. According to what is the statement? According to the law of parallelogram states that if two vectors are acting at a point in equilibrium, it is represented by both magnitude and direction, and the resultant line is also represented by both magnitude and direction of a in the parallelogram. That is the statement of a law of parallelogram. What is the explanation? The explanation of the OABC. The OABC is the parallelogram. OABC is the parallelogram, and vector A and vector B be the two vectors. The length of a OA, vector OA is, that is vector small vector A. The OB, vector OB can be written as small vector B. The resultant line OC, it is represented by resultant line. This is a representation of a parallelogram. The OC line is called diagonal line. That is also called resultant line. And the OA and OB is called adjacent sides of a parallelogram. Adjacent sides of a given parallelogram. And that is the length of a, the OB vector can be written as vector A, and OB, the OA vector can be written as vector A, the OB vector can be written as vector B, and the OC vector can be written as vector R. This is the explanation of a law of parallelogram. What is the difference between triangle law and law of parallelogram? The triangle law, what is the use of this triangle law? It is a triangle law it is used to measure the sides of the length of each side. To measure the length of each side of a triangle. But that law of parallelogram is, it is used to measure the both angles. Alpha is the angle, and OA and OP is the sides of adjacent sides, to measure the both angles and sides of a given parallelogram. That is the difference. That is the use of the triangle law and law of parallelogram. Very important 2 marks question. That is there are two, the addition of a vector. The first, the algebraic of a vector is, it is classified into two different types. First one is the addition of a vector. Second one is subtraction of a vector. What is the meaning of addition of a vector? The addition of a vector is, if vector A and vector B, the any two vectors, the sum of the two vectors is called, that is addition of a vector. That is vector R is equal to vector A plus vector B. That is also called triangle law. There are two different laws of addition of a vector. Triangle law of addition, the triangle law of vector addition. Second one is the parallelogram law of vector addition. According to the triangle law states that if two vectors is acting at a, what is the statement? If two vectors is acting at a point in equilibrium, it is represented by both magnitude and direction of a two sides of a triangle, and the resultant line or resultant force or resultant mass both are same. Mass, force, line both are same. The resultant line, it is also represented by both magnitude and direction of a three sides of a triangle. That is the statement of a triangle law, and that is the equation is vector R is equal to sum of the two vectors to sum of the other two vectors. And law of parallelogram. What is the statement of law of parallelogram? According to the law of addition of a vector, the law of the parallelogram is states that if two vectors A and B is the two vectors, vector A and vector B be the two vectors. If two vectors is acting at a point in equilibrium, it is represented by both magnitude and direction of a parallelogram, and the resultant line, it is also represented by both magnitude and direction of a in the parallelogram. That is the law of parallelogram of a vector, addition of a vector. That is the difference between triangle law and parallelogram. Next concept is, what is the expressions for magnitude of a resultant and the direction of a resultant? Expression for, that is 5 marks question, very important. Expression for magnitude and directions of a resultant. Magnitude and directions of a resultant. Magnitude means that is a capital R. Magnitude of a resultant is, that is a find the capital R. Direction of a resultant means that is a theta. Theta is the direction, angle, direction of a resultant. First to find the resultant of a the magnitude of a resultant. Find the capital R value. First to draw the, how to derive? That is first to draw the parallelogram. That is called parallelogram. That is the parallelogram is O, A, B, C is the parallelogram. That is draw the diagonal line. That is the resultant line. Capital R is the resultant line. The OA can be represented by the vector P. The OB can be represented by vector Q. Vector P and vector Q is the two vectors is acting at a point in equilibrium, and vector R is the resultant line. It is also acting at the point in equilibrium. At a theta is the angle. Theta is the angle of the parallelogram, and alpha is the, that is also angle. Okay, now if consider in the parallelogram, OABC is the parallelogram, and OA and OB is the adjacent sides of a parallelogram. That is the vector P, vector Q be the two vectors is acting at a point in equilibrium. the diagonal line that is called OC. It is also called resultant line. The resultant line is also represented by both magnitude and direction. The adjacent sides P and Q, the OA and OB, it is also represented by both magnitude and direction of the parallelogram OABC. And draw the line OD is perpendicular to OD line. Draw the line. The line OD is perpendicular to what? OD line. Draw the line. The OC is perpendicular to OD line. First find the what? The magnitude of a resultant. That is the diagram and explanation of a parallelogram. According to Bayesian statement of law of parallelogram, law of vectors, assertion of a vector. That is the OA line. That is the OA line is extends certain distance join the OC line. That is the CD line. The CD is perpendicular to what? OD line. See how to find the capital R. From the triangle OCD. That is the theta is the angle. That is also angle. From the triangle OCD. What is the angle? That is the triangle OCD. According to Bayesian Pythagoras theorem. What is the Pythagoras theorem? The diagonal line must be is equal to sum of the adjacent sides. The diagonal line is called OC square. The sum of the adjacent sides, that is the CD and OD. That is the OD square plus CD square. OC square is equal to OD square plus CD square. That is the Pythagoras theorem. The OC square, this is called OC. What is the force? That is the resultant force is capital R, that is R square. The OC can be written as R square. And OD, the OD, that is the OD line. OD is written as sum of the OA plus AD. That is OD can be written as the sum of the OA plus AD whole square plus CD means that is the CD as it is. That is a CD. That is a CD is as it is. That is a CD square as it is. The CD square is as it is. How to find the CD square or the OA plus AD whole square? That is the A plus B whole square formula. When apply the A plus B whole square formula, that is R square is equal to OA square plus AD square, A square plus B square plus 2AB. A is into OA into AD. Okay, now that is the A plus B whole square. A square plus B square plus 2AB. A is called OA, AD is called B. Okay, now plus CD square is as it is. Or the R square is equal to OA square. See, in the diagram shows OA square. What is the distance? The vector is P square. That is P square plus AD square. AD square means this line. There is no distance as it is, right? Same. AD square plus 2 is as it is into OA. OA can be, according to diagram, OA can be written as vector P and AD is also same. AD, there is no distance. AD is also same plus CD square is also same. Okay, now first to find the values of AD and CD. Now find the values of, this is the first point. Find the values of AD and CD. Find the values of AD and CD. First AD value. Find AD. Find the AD value. How to find AD? See, this is the AD line. from the triangle ACD, from the triangle ACD, it is the theta. AD is called, that is a horizontal line at angle is theta. The horizontal line means that angle is taken as cos theta. By using a definition of cos theta is adjacent side by hypotenuse side. Adjacent side by hypotenuse side. It is theta. This is called opposite. This is called hypotenuse. This is called adjacent. The adjacent side is AD divided by the hypotenuse side is AC. Cross multiply. That is AD is equal to AC into cos theta. AD is equal to AC cos theta, or the AD is equal to, one second, the AD is equal to the AC, that is AC means AC must be is equal to, the AC must be, it is AC line is parallel to what? OB line. That is AC must be is equal to OB. The OB value is what? What is the value? That is a vector is Q. That is Q. That is AD is equal to AC is Q at angle is cos theta. That is the AD value. That is called AD value. Then find the value of CD. Find the value of CD. Find the value of CD. How to find the value of CD? The value of CD is, see in the diagram shows, the parallelogram shows, this is the CD line. It is a vertical direction. The CD line is called vertical direction. That is, the vertical directions means from the triangle ACD, as it is same triangle ACD, from the triangle is ACD. Vertical at angle is theta. Theta is the angle. The vertical direction means that is the angle is sin theta. What is the definition of sin theta? It is the opposite by hypotenuse side. Opposite by hypotenuse side. In the diagram shows the triangle ACD, the opposite distance is CD. Right, opposite side is CD. The hypotenuse side is called AC, cross multiply, or the CD is equal to AC into sin theta. The CD is equal to AC sin theta, or CD is equal to AC. The AC is parallel to OB. What is the vector? Q. The AC can be written as Q at angle is sin theta. At angle is sin theta. That is the value of CD. That is called the previous equation, R square is equal to P square. That is called equation number 1. The AD value is called equation number 2. The CD value is called equation number 3. The equations 2 and 3 is substitute equation number 1, we get the values of equation 2 and 3 is substitute equation number 1, we get. From the equation number 1 can be written as, what is the equation number 1? R square is equal to P square is as it is. The AD value, what is the AD value? Q sin theta, but square is there. That is the AD can be written as, that is plus Q square cos square theta plus 2 into 2 is as it is, force P is as it is, and AD value is what? Q cos theta. AD value is Q cos theta as it is, cos theta plus CD value, square is there. The CD value is Q sin theta, but square is there, that is Q square sin square theta. sine square theta, or the r square is equal to p square plus c in this equation q square cos square theta, q square sin square theta. Q square is the second term and fourth term. What is the common factor? Q square is the common factor, that is the take outside, that is cos square theta plus sin square theta, bracket close, remaining term is plus 2pq cos theta, 2pq cos theta. But the sin square theta plus cos square theta is equal to 1, that is the trigonometric formula. The sin square theta plus cos square theta is equal to 1, that is the trigonometric formula. Okay na? That is the r square is equal to p square plus q square, cos square theta plus sin square theta is equal to, that value is 1, 1 into q square is q square plus 2pq cos theta, or the r is equal to the square is shifted that side, that is the root, it is converted to root, that is p square plus q square plus 2pq cos theta. This is the expression for what? The magnitude of a resultant, where r is a capital R is called, that is the magnitude of resultant, p and q be the two vectors, and theta is the angle, theta is a angle. This is the expression for, that is called what? That is the expression for the magnitude of a resultant, magnitude of a resultant. Once again listen, what is the expression for magnitude of resultant? First to draw the parallelogram OABC, and that is a vector p and vector q is the two vectors is acting at a point in O, and alpha and theta is the angles. Draw the diagonal line, that is called OC is the diagonal line, that is called resultant vector. Okay now, next draw the line CD, extend the line OA, it is the CD line is, it is perpendicular to OD line. Okay now, the CD line is perpendicular to OD line. Next, find the, that is the diagram and explanation part of this expression. From the triangle OCD, by using a Pythagoras theorem, OC square must be is equal to sum of the OD square plus CD square, that is a Pythagoras theorem. OC can be written as, what is the distance? That is the resultant is capital R square. The OD can be written as OD, this is the OD, sum of the OA plus AD whole square plus CD square, or the R square is equal to OA square, A plus B whole square formula, plus AD square plus 2OA and AD. Okay now, or R square is equal to the OA distance is what is the vector? P square plus AD square is as it is 2 into OA is called P, AD is as it is, CD square is as it is, that is called equation number 1. Equation number 1. Then find the values of AD and CD. How to find? See, the diagram shows CD is the horizontal line at angle is theta. By using a definition from the triangle ACD, from the triangle is ACD, CD is the horizontal line. By using a definition of cos theta. What is the cos theta? That is the adjacent side by hypotenuse. Adjacent side by hypotenuse. What is the adjacent side is? That is a, see in the diagram shows, that is a theta, that is called opposite side, hypotenuse side, that is adjacent side. The adjacent, the cos theta is defined as adjacent side by hypotenuse. The adjacent side is AD, the hypotenuse side is what? AC, or AD is equal to AC cos theta. Therefore, the AC is parallel to OB, that means what is the distance? That is what is the vector? Q. Therefore, AD is equal to Q cos theta, that is called equation number 2. Equation number 2. Then find the value of CD. What is the CD? CD is called vertical line. The CD is called vertical line. Vertical line means at angle is theta, the vertical direction can be taken as angle is sin theta. The sin theta's definition is opposite by hypotenuse. It is opposite, that is called hypotenuse. The opposite is CD, the hypotenuse is CA, that is CD by AC, cross multiply. That is CD is equal to AC sin theta, or CD is equal to the AC line is parallel to what? That is a OB line. OB line. Next, see the AC distance is Q sin theta, that is called equation number 3. The equation 2 and 3 substitute equation number 1. From equation number 1 can be written as R square is equal to P square plus the AD value. What is the AD value? Q square cos square theta plus 2 P AD